Joining me is Dr. Rob Robinson, Head of Bragg Institute at ANSTO. Dr. Robinson, in simple terms, can you explain the key roles and objectives of your institute?
We're the scientific face of the new opal reactor, and we use the beams of neutrons, which are neutral particles that make the reactor go, and we use them to do science. And in fact, we work with scientists in universities, industry, government, from Australia predominantly, but also from overseas. So we essentially collaborate with those people and use the neutrons, which sort of behave a bit like light or X-rays, and but are different. And we predominantly use these to study materials or materials in action, and a little bit of biology as well. But ultimately, we try and make our users, which are university people, predominantly happy. And the net result is that we create great scientific research.
Doctor, what are the major benefits to the community from the programs being pursued?
There are two real benefits, I think. One is that the knowledge we do underlies a lot of important technologies, whether it's the sorts of things in your laptop, like the read head or the hard drive, or almost anything that you can find in your garage or your kitchen, contains things going on the nanoscale, which we can measure. Now, we won't go and solve, very rarely will we solve specific problems, say for the paint industry or the food industry or whatever, although occasionally we do that, but we contribute to a body of scientific knowledge that underlies those things, whether it is chocolate or food or shampoo or paint or lubricants or whatever. So that's one benefit. The other benefit is that we're really a flagship for Australian science, and that will actually attract talent back to Australia or into Australia and give some of our collaborators, particularly in the universities, a leg up in competing with the Americans and the Europeans.
What are some key research results produced by the Institute, and how would you measure their impact?
Well, we are working on food, for instance, with CSIRO, and in fact, one of the problems that we're working on is trying to understand a type of starch that can go through one's digestive system without being digested, at least in the upper intestine, properly, and gets attacked by microbes in the lower intestine, and that's highly correlated with colorectal cancer, but it's not understood. And so we are working with CSIRO and Food Science Australia and the food industry to try and get a microscopic understanding of what's going on, and then maybe to optimise, the sorts of things that might eventually go into your breakfast cereals.
Internationally, what would you say is ANSTO standing in the field?
I think that varies across the organisation, but in what we're doing with the new opal reactor, our ambition is to be in the top 3 in the world. I don't think we're there yet, and we're probably towards the top of the second division at the moment, but I think when we really are fully going with the new reactor, we should be in the top 3 in the world.
How is the research funded?
Predominantly from the Commonwealth government, just like research in the universities. We do a little bit of commercial work. Probably more significant than that, we have some substantial inward investment from overseas. We've got about $8 million worth of in-kind investment from Taiwan and a smaller amount from New Zealand, and we're looking for more.
Doctor, what do you see as the major challenges in your area of work?
There aren't many areas where Australia's really at the top of the pile in research, and so giving researchers here the sort of sense that we're really there in the big time. I spent a large portion of my career in the United States, and with the tools we've got here, we can do just as well as pretty much any of the institutions there. So I think the sense that we can achieve the same sort of success that the country does in sports, say, that we can do that in science, and I think we can, but sometimes we don't believe it ourselves.
From a personal point of view, what do you find most rewarding about your job?
Well, I moved to Australia 10 years ago, and have been building up the institute from scratch since then. When we started, I could look out of the window and it would have been bush, and so we sort of essentially built up the institute from scratch, and that's just a wonderful opportunity, and has been great fun to do that. And not many people get a chance to do that. So that's probably that, and the combination of seeing the people involved grow themselves and get that sense of achievement out of it. That's probably the most exciting thing.
And lastly, why did you choose science as a career? And what would you say to someone considering this for their future?
That's a very good question. I mean, I took a bit of a haphazard path through this, although I was always good at mathematics in school, and actually I always found physics very difficult, and it's still difficult, although I do it as a professional. And in fact, I taught high school earlier in my career for a while, but after a while, I really wanted to see what I could create myself. So one of the exciting things is to be really out there on the frontier where nobody's gone before, and to be doing things where we don't know the answers, and to be discovering them. And that's something one gets to do in research. So that's probably the reason why I chose to go back to science, if you like.
That was Dr. Rob Robinson, head of Bragg Institute at ANSTO.